Hello. Hello, check. Hello, check. Hello.
NI-based technologies, and Sir is passionate about engineering education. He has delivered more than 350 technical lectures and conducted numerous hands-on training sessions and faculty development workshops across 200 plus engineering institutions in India and Sri Lanka. His areas of expertise include lab view, RF, and data acquisition, wireless sensor networks, FPGA based embedded systems design. We are delighted to have him with us today. Now, without further delay, I invite Mr. A. Manimaran sir to deliver today's technical session. Sir, please.
I don't think so, mic required. I don't think it's mic required. They will be directly audible. We'll see if they didn't get me, then I'll take mic. Just arrange me water bottles. You can- Yes. Process. We audible. So do I have markers? No. Oh, yeah. This one? Yeah. Yes, good morning. Great. Fine. Today's topic will be on NI MyRio hardware based FPGA programmable or designing or hardware configuration. So all these stuffs which you are going to see today. So why I preferred this particular hardware is this is one simple portable FPGA based device and it's easily programmable and more importantly it is available in campus. So I can have a hands-on with everyone and I can use them. So how exactly we can program FPGAs, how exactly we do compilations, what is the importance of graphical program for FPGA. I will not write a single line of code. No Verilog, no HDL, nothing. It will be on LabVIEW. So I'll be doing a graphical program, how it converts. So that's what we are going to do. And before I proceed, my name is Manimaran. I am from a company called VA Solutions, India Private Limited. So we are associated with National Instruments for last 14 years. I am there in VA Solutions for last 13 years. So we provide support to NI throughout India and other countries as well. So all NI related training, services, sales, support, we will take care in terms of academic as well as in terms of industries. We are also one of the alliance partner of National Instruments. So we do services for NI. So when we get into FPGA, so what exactly comes into everyone's mind is, so how exactly we are going to configure this FPGA hardware? So how exactly we are going to program this FPGA hardware? Because everybody knows these all things are available inside FPGA there. Yes, these all things are available in FPGA there. And if I want to tell you in industry how things will happen is, companies, those are all making data acquisition systems. They'll all only procure FPGA based processors. Why they want to buy FPGA based processors? If they want to improve their computing to be in a faster pace, they want to configure an ADC of a particular range. So FPGA will help them to do that work because microprocessors will have limitations. So the speed wise you can't proceed further. Whereas FPGA wise it is something as a wire connections. Yes, if you switch on a light, immediately light goes, right? The similar way your FPGAs will work faster. Based on the clock rates, you can go with it. And in many critical applications, they will rely on FPGA based modules. So very simple is the military standard hardwares, 1553 protocol or any other protocols, whatever they go with, they all will go with FPGA based elements over there. So all their chips, everything will be configured based on this. So how they do with it? Yes. So, and because the rate is, for example, if I have one FPGA hardware which is of 40 megahertz clock, what could be that time? So 40 megahertz clock, what could be the time? The clock frequency of your FPGA will be 40 megahertz clock. So what could be the time? So T equal to 1 by 40 megahertz. So which is approximately equal to, so 25 nanoseconds. So think your computations can happen. This is 1 second. 25 nanoseconds you can complete your work. One cycle. What do I mean is, in a simple form, if I want to tell you, you will be writing one while loop concept code you will write, or one for loop you will write. One loop iteration, zeroth iteration to first iteration. Zeroth iteration will get complete within 25 nanoseconds. Let's say if I have a 80 megahertz clock, so do you understand in what way this could be beneficial there? Because everybody knows what is FPGA there in it. Yes. So I don't want to explain what is FPGA there. But why FPGA? The reason is these all options. So this is how my entire LabVIEW program will get converted. So this is how my entire LabVIEW program will get converted inside FPGA. I'll be writing as a multiply. Yes. All our digital electronic subject. Yes. OR gate, AND gate, NAND gate, Boolean expressions. Yes. Sum of product, product of sum, everything will be there inside it. Yes, the entire code will do it. So who will do this work? Compiler will do this work. Whatever I write in LabVIEW, FPGA will not understand. FPGA will understand only zeros and ones. Yes. So how exactly these things will be converted there? So how exactly these things will be converted is, so for example, whatever I write over here in a LabVIEW program, which will be in a form of graphical so A, B, C, if I get a D, if I put something in a graphical, so I have an FPGA which will understand only zeros and ones. So in between something will do my work. What is that? In between something do my work. That is called LabVIEW FPGA compile form. So the graphical code which will convert into a bit file. So this conversion will be done through my LabVIEW FPGA compile form. So this FPGA compile form has been provided by Xilinx. So either it can be ISE or it can be Vivado or different kind of compilers we have. So based on that, it will do that work. So depending on the versions, OS support, multiple factors are there. Yes, which will do this. So now, how exactly the things will be present is, those who are learning FPGAs now, how exactly it will be is, whatever you have seen, these portions, right? These are all programmable interconnects. With these are all programmable interconnects, and this is your logical portions there. The individual logics will get built this portion only. The individual logics will be built here. And this side, whatever we have, these are all pinouts. So if I want to tell you, you can configure, which means when you are defining your FPGA, how many inputs, how many outputs, how many has to behave for analog, how many has to behave for digital. Excuse me. If you are configuring it, you can configure through based on the available IO pins there. And literally, these all logics will get built based on the available billions of logic gates present inside the FPGA. Because in a simpler form, if I want to tell you, if you are buying a phone, what do you look for? If you're buying a mobile phone, what do you look for? Specifications, camera, this much pixel, RAM, memory. Yes, you will say 8 GB RAM, 16 GB RAM. Yes, 1 TB, 256 GB, you are looking, right? Similar way, when I choose FPGA, I will be looking for how many millions and billions of logic gates present inside there and how many IOS options I can access. So based on that, I choose in the sense I can do more computations inside it. So the memories will be there in it. Am I clear? So if I want to tell you how you can perform one numeric addition, for that there is an equivalent binary logic operations are available there. Am I clear? Yes or no? Yes. So equivalent binary operations you have there. So that binary equivalent logic will get built inside your logical portions there. And this is something from my house, I am going to my friend's house. I can go through anyway. Yes. I can take the third lane and I can take the third left. I can reach there. Or I can go through the outer ring road of the apartment. I can go there. Or I can enter every house, come out, and I can get in there. Yes. So how do you configure? No, the system will get configured there because you are going to define AB in, Z is out. That's it. So you are defining a pin. Which are the pin over there? So pin number 7 and pin number 8 is for in. Pin number 32 is for output. So it will map through that. Am I clear? Yes. So the ideal operation or a surprising factor in your FPGA is parallelism. So what is parallelism? Yes. Parallel processing. Yes. In a simple form, if I want to tell you what is parallel processing is, you know Rajinikanth? Shivaji Motabas signed in 2 hands, right? That is parallelism. I cannot give you an example as a computer working on a Word document by listening to a song. No, that is sequential processing. Because there is a minimum time gap which we couldn't notice. So the system will change the process allocation from one application to the other application. So that's why if you see so many applications will be running over there in your computer. They all will go on other. If there is a higher priority comes, interrupt comes, it will give higher priority. So they all will run in a sequence one after the other. It's not parallel. Am I clear? So parallel in the sense both should happen at a time. So how exactly you can achieve that? In your FPGA based systems, you can achieve it there. Yes, for high computations, high processing, they can go with it. The reason for going for a FPGA based system is these 4. Yes, one is highly reliable, highly deterministic, true parallelism, reconfigurable. Okay, no human can do this work. No human can do this work. See, for example, if I'm trying to recruit you, I'm paying you monthly 35 lakhs. How many of you are interested in taking up this job? You want me to tell you again? I am planning to recruit you. I am trying to pay you 35 lakhs per month. How many of you interested to take up this job? Nobody have asked me what is JD. Job description. Yes. The job description is open and close the door. Yes. Or if I want to switch, okay, switch on, switch off the light. Again, you didn't ask me how many times. You didn't ask me how many times. So, 8 times per day. 8 times on, 8 times off. Every 1 hour. Or if I want to conveniently give you whole day, either starting 9 o'clock, 8 times on off, leave, or 4:55 on off, leave. Choice is yours. If I put it every 1 hour, exactly at 1 hour 00 second, you will turn on. Determinism comes there. I have to exactly turn on. How every 1 hour there is a bell sound rings up there. There is a time, right? As soon as that time comes, church bell rings there every 1 hour. It has been programmed. Yes or no? And people are not ready to take up a job of 35 lakh per month for on-off operation. After 1 month, it will be enjoyable. Second month, you will give me 35 lakhs. Please relieve from this job. I don't want this job. Because you're not reliable. Today you will be working here. Tomorrow you will switch over. Because that bloody machine will be still lying over there. Unless until I feed it 5 volt or 10 volt to it. Yes or no? System is reliable. If I give 2 batteries to it, next 1 year, I don't want to worry. Still supply is there, it will work. Yes or no? What is the sufficient supply required for the machine to function? If I feed, system will work properly there. It will not malfunction for 2 days, then it will not work properly for the next remaining days. No, it will behave the same way. Unless until there is no change in the inputs. Am I clear? Yes. So, what exactly is highly reliable is the system has to function properly as per the defined requirement. Deterministic is time. Whether can you rely on the time? See, I need some system which will save my nuclear plant. Whom do you rely? Sir, I'll be here 24/7, sir. I'll not sleep. Not even a single second. If any chain reaction happens to occur, I'll immediately close it. No, you can't rely on that fellow. He cannot be time deterministic. Yes, he can't be time deterministic. See, many companies, or especially for banking sectors or these stock markets, why do they want to automate things? Because there can be so much of human errors can happen. Yes, there are so much of human errors can happen. For example, let's say if there is a banking company, if they are trying to go on a scheduled maintenance, I have a 5 minutes difference in my watch. But already the time started for it. But I would have not closed the session here. So what will happen? I'll get multiple enquiries there. Multiple people would have done some X number of transactions. Now all these transactions will be queued up and it will have not settled. So what will happen? All these transactions will go waste. If it is only a local bank, fine. Yes? Think about if it is a global bank and different geographical time locations if they are functioning. Annual one time if they are doing a common maintenance for the entire systems, how they are going to do. For the 2 minutes or 5 minutes of server difference, what you have there. So that's the reasons timing is very, very important. So we'll not come to know whether it functions within that particular time period or not. So if you are performing through FPGA based, it is deterministic, time deterministic. Am I clear? Parallelism. So what is parallelism is, as we have seen there, multiple applications you can run through it unless until there is some extra space in it. Yes, it's something as acquisition can happen every time. It will run parallelly. Once I acquire there, I'll put it into a queue. I'll push it over there. So acquisition can run. I can do the analysis in another portion of a loop. So that acquisition will not get disturbed due to the analysis which is running over here. Let's say if I want to apply a filter, or if I want to store the data or log the data, so everything I can do over here. Am I clear? Yes. So reconfigurable. So now the same job comes, on and off jobs. 35 lakh times switching on, switching off, not possible by a human. Yes, switch on, switch off light. No, this is not this job. Now you want to do a door open close job. No, you will come and say, no, I have been recruited only to switch on, switch off this work. I'll not do that work because you are not reconfigurable. I cannot program them. Yes. So if I can reconfigure it, I can easily do there. See, for example, let's say if I have a bottle filling unit. Yes, I have a bottle filling unit. So I have a half-liter water bottle filling unit I have there. Excuse me. Now I want to change the bottle filling plant as a 1 liter water bottle filling unit. So what should I do now? Should I want to construct one more plant? Tell me guys, what I'm supposed to do? You have to change few parameters. Either you can increase the open time of your valve for 5 seconds if half-liter fills. I need to keep that valve remains open for 10 seconds so that it will fill 1 liter. Yes. Or I can increase the flow rate of water for the same 5 seconds so that it will fill easily there. Am I clear? Yes. So if I have a reconfigure option, I can save that another 50 lakhs to implement the plant. Because already I spent some X amount to build a plant over there. So now I can do all these changes there in it. So this is how we'll be writing LabVIEW based programs there. So there is no single lines of code we'll be writing in it. Whatever we'll be taking in terms of LabVIEW based programming there. There are different ways you can write a program with your hardware. For example, this is how NA based DAC systems are there. There are different kinds of RIO boards we have. What is RIO? RIO stands for Reconfigurable input and output. So these reconfigurable inputs and outputs will come up with the different options we have. We have something called as C-RIO, compact RIO, SB RIO, Flux RIO. Yes, some different options we have over there. These are all different types of NI boards available there. So what is compact RIO is, Excuse me. See, these devices are very, very compact. In what terms? Compact Rio comes with a separate processor selection, controller selection, and IO module selection over there. Yes, whereas SB Rio comes under compact Rio and SB Rio. SB Rio comes under single board. In a single board, RT controller is there, FPGA processor is there, input and IOs are there, input and output elements are there. Okay.
Laptops, tables, laptops.
Another 5-10 minutes I will start. Yes, so these IOs are there. The major difference between your compact Rio and SB Rio is, in your compact Rio, whatever we have is, let's say I have a dual core processor which is not sufficient for my operation because memory, RAM, everything will sit into your here controller, main controller, real-time controller. Linux OS will be there in it. Because Windows OS, suddenly some antivirus pops up, my system will get blank. If Windows Chrome is getting updated, excuse me, then my system will hang. Yes, I cannot rely on this operation. Yes, so I will go for a Linux-based systems, for real-time systems there. So here, if dual core is not sufficient, I will prefer for i7 processor. If 500 MB is not sufficient, I will go for a 4 GB RAM. Yes, if it is 120 MB is not sufficient, I will go for a 250 GB RAM. I can choose a different type of processor there. So I have a FPGA backplanes in terms of 4, 8 I have. So 4 slot or 8 slot I can choose, depends on my options. So I have IO modules. So whether I need 8 analog in or 4 analog in, or I need 16 analog in, or I need 32 analog in, I can choose accordingly there. Am I clear? Yes. So if I want to have a different pin node terminals over there, RJ50 type or BNC type or a screw terminal or DB9 connectors, I can take. Am I clear? Yes. This is compact Rio. In single board Rio, what it is in one board you have everything. Controller is there, FPGA is also there, it was also there. If you want to go for a high-speed controller, maybe that board does not have a more number of FPGAs in it. What do I mean is, let's say I have a 2 billion gates FPGA in a compact Rio. Same 2 billion gauge FPGA I want to choose here. Okay, I choose. But the single board Rio of 2 billion gate FPGA has only a dual core processor. I don't have a i3 processor there in it. So you have to compromise for it. Am I clear? In a simple term, SB Rios are ready-made shirts. Compact Rios are tailor-made shirts. If I want the front one color, back one color, I can stitch. If I want one hand as a full 8 channel inputs, if I have one hand as a half sleeve or 4 channel inputs, I can configure with the modules. But in SB Rio, this color is very good. But the size of shirt is only in medium. There is no XL or large. So what do you choose? The same option. So it's similarly, saree is not good, but border is nice. So which way you adapt to it, you have to adapt for it. Am I clear? Yes. So how exactly you have to go for it? Based on the application we chooses. So controller speed is not important, but FPGA size matters. Excuse me. So for high speed computing, we need a more FPGA there. So we choose there. Am I clear? Because the entire processing is going to happen inside FPGA, not on a controller. Controller is only to say communicate. If somebody pings you, how you are going to react for it? So how you are going to take it from there? Am I clear? Yes. Okay. So this particular hardware, what do we have here? So this particular hardware, what do we have here is, so this is Myrio hardware. This is a Myrio hardware. This one hardware has everything inside it. RT is there, FPGA is there, analog in, analog out, digital in, digital out you have in it. And it has a accelerometer in it, LED in it. Everything they have here. UART serial port, you have everything in this. So this comes under SVRIO because in a single board, everything you have. And one interesting factor about this particular hardware is this comes with a zinc processor, Z10YQ. Zinc processor, which comes under SOC format. What is SOC is system on chip. So what is SOC system on chip is, in a single chip, I have an RT controller, I have an FPGA processor are embedded together. Earlier only FPGA you have. We call it as a discrete FPGAs. Take only FPGA, give power supply to it, write a program for it, assign IOs, take out. Very, very similar to your 7432, 7486, 7400 logic gates you use, right? This pin power, this pin ground, this pin input, this pin output, discrete FPGAs. So here it is SOC. There is another version to it, SOM. Because this plus IOs will be there. So this can be analog, digital, custom. Yes. So you have different options you had there in it. So what is SOM is, you don't have any option because RT you have in it, FPGA you have in it, IOs also you have in it, analog in, analog out, digital IO, custom IO. Everything is there in a single system on module. SOM it is. Yes. So these are all very old concepts. These are all very old concepts because the system on modules have come much earlier, 7-8 years before itself. The Kintex FPGAs, everything you have got with this particular and you can use there. Yes. So this module has released 12 years before. In 2012, NI have launched it. Yes, 12, 13 years they have released. It has Wi-Fi in it. So think about how fast the industry grows. We might get an opportunity to use this today, but this technology is already available in market. Am I clear? Yes. So now they try to, what they put it is, now they all try to put more work on how to make the system more efficient. How fast it can work. And moreover, if you see, I have a controller in it, I have an FPGA in it, I have multiple circuits in it, but I don't have any ventilations here. There is no fan here. Yes, I'm going to feed a 12 volt supply to this. Yes, I'm going to feed a 12 volt supply to this. Even 12 volt battery also will support this. Yes, whether you built a drone on it or whether you built a rover in it, your choice. Because I have a controller in it. Yes, I have a ARM Cortex A9 processor I have inside it. So if I want to make a rover or if I want to make a, quadcopter or a drone, I can easily use with this. And I have an inbuilt accelerometer, triaxial accelerometer I have in it. Plus or minus 8G I have. Yes, this particular Myrio hardware has serial port and everything you have in it. So for example, this NA Myrio, what you have is, I hope it will be visible what I write here. So this particular NI MyRio has 10 analog in, 6 analog out, 40 DIO, 2 UART, 4 LED, 1 triaxial accelerometer I have, 1 Wi-Fi I have in it, 1 USB I have in it on board. So host to USB. So you can connect additional storage. You can connect through a additional storage and you can connect. You want to connect a webcam? Yes, you can connect a webcam and you can work on it. Excuse me. And I have a Wi-Fi which can hotspot, which can connect to an existing network. Yes, so you can easily use with it. These 40 DYOs are shared among multiple operations I have there. These 40 DIOs are shared with SPI, I2C, PWM, quadrature encoders, digital in, digital out. So multiple operations these 40 DIOs will do. So you can configure them for what application you are going to use that. Am I clear? Yes. So you can easily configure them how exactly you can work it. This particular hardware has a 12-bit ADC. So 12-bit ADC it is. And we have a 500 kilo samples per second, 375 kilo samples per second you have there. So analog in, analog out you have there in it. Yes. So these modules where you can easily access through it and you can work. So 500 kilo samples you already have. So easily you can access through it. MyDAC has 200 kilo samples. The lower version which does not have any FPGA in it. Yes. So this will work with plus or minus 10 volt range. This side, one side. The other side work with 0 to 5 volt line. And it has a 5 volt supply, 15 volt supply, 3.3 volt supply you can take. Yes, you can easily work with it. We'll share. We'll share this hardware. We'll share to all the college laptops. Because college laptops only we have installed it.
We were there, like, we had some exams, so we couldn't attend the whole session.
What not supporting?
So like, does it have an internal step up booster? Like, like you have said, like we'll be feeding mostly 12 volts on our
1.5 amps, 12 volt, 1.5 amps, okay, 2.5 amps. Sir,
After you open, skip file or something.
I'll tell them those things. Excuse me all. First, check whether your Myrio is powering on. The adapters what you have, connect your power adapter to it and check whether your Myrio is powering on. There is one terminal for power, one terminal for USB. Whatever. What are you searching for? Is Myrio powering on? Connect Myrio using a power adapter. How many of you didn't get power adapters? Connect Myrio power supply, switch on. There should be a blue color LED on your power. Whatever. Switch on. How do I shift to this? But adapter not working. What is the range of adapter? Use try this. Yeah, working. Don't disturb that. What is the range of adapters? 12 volts, 1 amps. This itself loose. Sir, you have any other video? Adapter issue. So do you get any some other power adapters you can use? Working? So you all please open LabVIEW. Before you open LabVIEW, connect your MyRio using USB to your laptop. One end of your cable will connect to your MyRio, other end will go to your PC. Connect properly. It will connect only in one direction. Yes. So now, as soon as you connect MyRio to it, did you get any notification? One device found, MyRio found or something? Yes or no? Below, you have any information? Launch, getting started wizard, launch IO monitor. Next, what do you have? Configure MyRio, do nothing. Below do nothing, do you have any other information? Okay. So now, this is one way that your hardware is getting identified for you. Yes or no? Select that hardware, go for launch getting started wizard. Choose launch getting started wizard. See, we need to understand two things here. One is we are using a real-time controller and an FPGA in it. So which means a new computer. So when the very first time you are starting a computer, you will be installing OS, formatting OS, so many things you will process and you do there. But every time when you turn on your computer, will you do that work? No. Okay, why do you format your computer? If the OS is not compatible for you, you don't understand it, so you will change it. Yes or no? So in this, one important thing you need to understand is what version of LabVIEW present in your laptop or a PC, the same version should be present inside your MyRio also. If not, if both are not in the same version, they cannot talk to each other. Both should talk to in the same version of software. Am I clear? The software present inside MyRio. Yeah, we will be installing there. There will be a OS inside. There will be a LabVIEW software inside. See, for example, we have PC, we have MyRio. So the PC may be with Windows 11 or with any other form. The MyRio has a Linux OS. But we are going to talk to a real-time computer. a different computer from my Windows computer. So if I'm going to communicate to it, if I'm going to have a common language, that is my LabVIEW software. So now the same LabVIEW software, what version do I need? If PC has LabVIEW 2021, my Rio also should have LabVIEW 2021. If it has the different versions, it cannot talk to each other. So you need to have a same version. So now we have an option of launch getting started wizard. Yes, choose launch getting started wizard. So you could come onto a found one device, select OK or select yes. Yes. Next. You didn't get that option? Begin 73. Why you not detected?
November 13, 40.
Wait. Huh? Rio 2022. Whose laptop is this? You have any extra USB cables? Hmm. See? The required software missing on my view. Install software required. Give next. See, once after you select your hardware and give next, is it looking for checking software on your hardware? Software error. Give mouse. Excuse me all, those who for hardware not detected, you can please switch off your Windows firewall. If you switch off your Windows firewall, then hardware will get detected. If hardware already detected and pops up, no issues because your hardware is already detecting. Don't do it. So, begin 78 player. Sit, it will take time. They didn't install software. check it and tell you one method how you can do things. Okay. Yeah. I'll be going with this option only. You cancel. I'll tell you how to do it. We'll have a simulation option. We'll do with that. Software installed. Next. Next. Yes. Go for launch IO monitor. Launch IO monitor. Launch getting started is that. Next. So there are two options. Do you have recommended and other? Software error. Okay, go cancel. So those who have got error while choosing for it, go to NIMAX. Go to start, type NIMAX. Go to start, type NIMAX. Expand remote systems. Expand remote systems. Under remote systems, you will get your MyRio there. Do you have MyRio? Yes. Under MyRio, do you have devices and support and you have a software? Expand software. Yes. So there, if you see inside MyRio, you have 19. Under MyRio, you have a software as 19. Compact Rio 19 or something is written. 19.0, 19.0. Our LabVIEW versions are 2021. So right click on software. Right click on software under MyRio. Right click on software under MyRio. Choose add or remove software. So username is admin. Password is nothing. No data. Okay, say okay. Nothing. You don't want to type anything. Empty is the password. NIMAX? How come? If LabVIEW is installed, obviously NIMAX will be installed. Apps NIMAX. NIMAX. Say close. Again, do right click. No, preserve settings for network configuration, network adapters. Format. Hey, what do you give? Format or what do you give? You gave for format disk? I didn't say format disk. I said add or remove software. Say, choose base system image. Say close. Right click on MyRio software. You have done right click on the MyRio icon and you have chosen it. You didn't expand for the software. No, below MyRio software. Right click, add or remove software. Do nothing. Allow access. Close. Right click on software. Go for do nothing. There is an option for do nothing. Sit. Go to NIMAX. Do nothing. No. Do nothing. You just go and come. We'll check and keep it. Right click on my video. Right click on my video. Right click on my video. Choose
Hello, check. Hello.
See, close your NIMAX, open LabVIEW. Close your NIMAX and open LabVIEW. Cable issue. Maybe. So it is not popping up. Somewhere check with a different cable. No. Begin 70 trial. See, open LabVIEW. If it asks you for begin 70 trial, give begin 70 trial. If it asks you to activate or evaluate, choose evaluate. Wait. Launch getting started, sir. No. Next. Or you it is communicating, man. Cancel. Software error. What? Close. Cancel. You also have chosen launch getting started wizard. What did you choose? No, that one. For them, I have wanted to check. See, close your pop-ups. What you have on top. Launch IO monitor. Configure Wi-Fi options here, right? Close. Close this. Close. So now, do you have an option called as create project? Get into create project. Get into create project. In his laptop, please install that e-shade there so that we can use that laptop to show. Probably once after we test all these things, last I can show demo through that. So now everybody will do hands-on. So when you go for here option, do you have anything called as MyRio here? Choose MyRio. So once you choose MyRio, do you have something called as right side MyRio project? Yes. So choose MyRio project. So once after if you choose MyRio project, you will have one screen. Don't look at my screen. This is different than yours. So there you have 4 options. MyRio connected via USB. Yes. If hardware is detected, then it will list out the hardware there. MyRio 172.22.11.2. Yes. But the problem here is we are using 2 different softwares there. For anybody, MyRio is not getting detected there. Okay. So for those who MyRio is not detected there, you have an option called as generic target. Everybody has. This is an option for those who don't have MyRio. Do you have generic target? So under generic target, you have 2 options. 1900, 1950. Choose 1900. This is for don't have. It's only for simulation. So now say okay here. So LabVIEW will finalize your options. Done? So is LabVIEW is creating a project for you? Yes? See, what I am doing is, look at here. What I am doing here is, I am trying to show you something similar to your MyRio system. I am going to go for a compact Rio system. So do I have any hardware? No. So I'll give next. I create a new system. So I'll choose one hardware system over here. Yes, I'll choose one hardware system over here. I'll say next. So now do you see here, I'll just add analog input module 9201. So 9211 thermocouple input. 9263 analog output. So how exactly you have all analog in, analog out, digital in, digital out you have in your MyRio. For my Stereo I can configure, I told you, right? So how many elements I need over there, I can configure there. So I'll just put one analog input module, one temperature module. Yes. One analog output module, one DIO hardware, one digital in, one digital out. So as of now, I left some 2 slots empty. So now it is creating a C-series modules and it is creating a project for me. Am I clear? So I have got a real-time computer. Under real-time computer, I got a chassis. Under chassis, I got an FPGA. Under FPGA, I got 7 modules. Sorry, 6 modules. Yes or no? Yes. I'll say finish. So now it is creating a project for me. Now you all have project, MyRio project. You all will have MyRio 170.22.11.2. Those who have chosen simulated module, you got 0.0.0.0. What happened? Yes, you all have. Yes or no? I'll save this project. Under desktop, I'll just save this. So VCFTP. So I'll save it as a Stereo project. For you, it is already saved as a MyRio project. Or you can also change location, no problem. So now if you see, under one project, I have 2 computers. Yes or no? Yes or no? So under one project, I have 2 computers. One is host Windows computer. Other one is real-time computer. Yes, I have a real-time computer. So now, whatever I'm going to create here, everything will be my RTVI, FPGA VIs I'll have here. Do you understand? Yes, when you expand your MyRio, you will have one VI called as main VI, but you will not have chassis. I'll tell you why you don't have chassis. You also can add there. Okay. So one here, double click on your main VI, new VI. I'll save this. I save this. You all open your main VI, run your program. So on the lab view left side, you have an arrow mark. Below edit, just click on arrow mark, right arrow key. See, below edit, you have a run. This is deploying, so this will work here. Save changes. Save all. Close. Stop. So this system works. Sir, here you can install the reshape. I'll show you that. So now what I'll be having is, did you all open your main VA? So there you have something as an accelerometer code you have. Yes, accelerometer block you have. So now the same block, what you can do it is, you can add additional things. So right click on your block diagram, come down. Do you have something called as MyRio palette, MyRio VA, anything you have? Do you have anything as MyRio, iOS or something you have? Go to your block diagram. What happened? Go to block diagram, white color screen, window, show block diagram. On the top, window, show block diagram. Come down. MyRio. Hardware itself not editing. Wait. Someone have changed IP addresses as well.
Each board will have different types of
No, everything will have a same IP address as of now, because whatever you have taken there. So there you have MyRio palette. Right click on your white color space. Go to your block diagram. Under your block diagram, if you come down, there is something called as MyRio. Do you have? Do you have my Rio? Yes or no? So inside, do you have so many pallets? So let's say if I get into here, do I have the pin mark over there, the left top corner? Left top corner, do I have a pin mark? Just pin it. Just pin it so that you will have all options over there in it. Yes? Do you have something as these boxes you have? So no, do you have something as these boxes? So you have accelerometer, you have analog in, you have analog out, you have digital I/O, you have LED. No. Did you pin it or not? If you pin it, you will be able to see that. See, I wanted to show you what are all you have there in it. That's why I have asked you to do. So now what we need is, whichever we want to use, just drag and drop. Yes? Along with the accelerometer, if I want to include some LED, so choose LED block, drop it inside your block diagram. Choose LED block, drop it inside your block diagram. You have that accelerometer block, right? Keep it close to it. Okay, I don't know how you are all taking it. First, still you are there in front panel only. Still you are there in front panel only. Okay, so I'll tell you once again. Close all your VIs. Close all your VIs. Whatever VIs you have taken, close it. No problem. We can open it again. Don't close the entire project. Project should be open. Close only VI. Okay? You all done? Listen to my steps carefully so that you will get the same result. See here. Do you all have main VI? Double click on that main VI. Double click on that main VI. You all have got one gray color window with a graph in it. Yes or no? Stop button in it. Go to window. Show block diagram. Now you all have block diagram. In the block diagram, you have an accelerometer. You have a reset. You have a stop button, everything you have. Yes or no? Now, right click on this block diagram. That white color space. Come down. Do you all have my Rio? Go to that palette, pin there. Now you have something similar to this. There you have accelerometer. There you have LED, analog in, analog out, serial UART, PWM. Do you have those options? Now, already what you have is something similar as this. You have one square. After one square, you have. Yes or no? So in this portion, they have taken one while loop and they have kept it as this here. Do you all have that? So here you have one accelerometer which is connected to a graph and they are doing it. So now you are visualizing accelerometer. Along with, if you want to see some LED, what you can do is right click, which means already you have that palette LED you have, right? So in that palette, just drag and drop. LED block, drag and drop. When you drag and drop LED palette, you will get 4 LEDs options there. Yes or no? Whichever you enable and say okay, first enable only first two or 0 and 3. First enable 0 and 3 and say okay. So what will happen is only those two LEDs will be there. Whatever you configure, only those LEDs will come. Am I clear? Yes. So now, if you want to reconfigure, double click on that LED block. It will open up the same block again. There, if you want to add additional LEDs lines, you can enable them and say okay, it will configure the other. Now you got all. Yes. So now, you have one block. Right click on that block. You have LED line, LED 0, you have DIO 0, you have LED 0, you have LED 0. Right click on that LED 0. Do you have option called as create? Do you have option called as create constant, create control? Create control. It will create control for it. So similarly, do for all the remaining. I said keep it inside here, close to your accelerometer. Select, maximize, select this, drag and drop inside this. Control. Sir, this system can you share? I'll take my laptop. I'll keep this in tables. Should I disconnect from here? No, leave. Only my area alone I have to get a power. I have to need for this. See here, do you all have this? Yes. So now actually when your system got connected, how exactly you can do is when I run this code, when I run this code is getting deployed into the hardware. Yes, this code is getting deployed into the hardware. So now if you see here, this is a real-time computing. Yes. How fast it is happening is I'm barely touching this table, but still it is sensitive enough to pick the data there. And these are happening at a very faster rate. And if it is there, this delay is 10. I'm keeping this delay as 0. You see how fast this will be running now. Ten millisecond delay and this delay. Do you see here how fast it is? So the delay has been provided there only to show you how real-time acquisitions will occur there. Do you understand? So along with that, if I right click, I'll go for my palette, MyRio palette. In this MyRio palette, if I try to add something along to this, let's take an LED, I drop it here inside the acquisition portion, main loop portion there. So whatever the LEDs I require, I'll add there. Now I'm gonna create a control for these terminals. I create control, right click on every LED, create control, sorry. Right click, create control, right click, create control. So now along with this accelerometer, I have this LED connected there. So now whatever the changes I have done here, I have LED 2, LED 0, LED 1, LED 3. So now I run this program. So what will happen is whenever I turn on this, for any changes, I'm not doing any compilation. They are all RT program. So it's all gonna deploy there instantly there. So now whatever it is running inside an FPGA. So now I have one hardware here. So now it is standing. So y-axis is high. So red color is coming there. Is it visible red color? Or else we'll change the colors there. Wait. The line width, I'll make it bigger. Yes. So now when I do changes, do you see here now it is flat? I have a triaxial accelerometer. Z-axis is high. So up down will be Z-axis variation. So only green color is varying. Yes or no? So Z, X, Y. Up and down is Z. Front and back is Y. Red color. Yes or no? Left, right is blue color. Yes. So basically, if I make this stand, y-axis have gone one, red color is on the top, the other two have come bottom. So now I have these LEDs. So if I turn on this LED 2, I have LED 2 glowing here. Yes. If I turn on LED 3, LED 3 glowing here? Yes or no? So whatever logic's there, so we can keep with this. So now these LEDs are happening there in it. So now I'll just keep it over here. I'll say stop. Now what I'm going to do it is, anyway, we have these logics, we have these controls. I'll take this one. Now what I'm going to do it is, I'm going to check this. Which axis is varying, I want to understand. Which axis is varying, I need to understand. So if you see here, so if you see here, if any axis is high, it is 1. Yes or no? Or else it is 0. So if any axes are greater than 0.5, I'm going to make one LED high because I have 4 LEDs. So what I'm going to do is, I'll take comparison greater than or equal to, greater than or equal to, greater than or equal to. So X greater than or equal to, Y greater than or equal to, Z greater than or equal to, create a constant 0.5. So all elements will be compared with 0.5. So 0th LED, first LED, second LED. So I have one more LED which is not connected there. So now what I'll do is, I have something as a button. Or if I flip totally, I can keep over there. So that LED I can change anything. Yes, so any options I can do here. So now I create a constant, let it be true always. So always one LED will be glowing. So now file, save changes. I run this code. Now do you see all changes are getting deployed? We are not compiling because these IOs are already pre-compiled. Just like that, you take connect, program, deploy, close. Now what happens is, do you see 2 LED glowing? Yes or no? Why? Z-axis is always high. Yes or no? Yes? Z-axis is always high. So I'll show to my front panel. Yes or no? So now when I am tilting here, it should shift to the top. 2 lines are high. But when I make it, what happened there? This is always on, last step. Only this is varying. Yes or no? If I flip here, what happens? It shifted to 1 above because of x-axis is high. The other 2 have come down. Yes or no? If I pull further, only 1 is glowing now. Because I am making -1 for Z, sorry, Y. Z, X, Y. Do you understand? Y is -1, Y is +1. Now LED is glowing. Now no LED. Yes. So Y have become -1 to +1. Variations could you see there? Yes. So in this case, what you can take is, you can make your own logic and you can keep there. So now I am going to deploy a logic in it. I am going to remove from the system. So what I am going to do is, I am going to make it as a standalone system here. So what I am going to do is, I'll take this. I'll just try to put one logic for one LED here. Create a constant So I'll keep there. I'll take one button. I have my video there in it. I have a button at the backside of my video. I have a button over here at the backside of my video. When I press that button, the code should stop. Till then the code can run. So now what I'll do is, I'll say okay here. I'll connect this with one more OR gate. Insert Boolean palette OR gate. This value over there. So clean up. Sorry. So now what is happening here is, I'm trying to build a logic for this LED on off. I'm trying to build a logic LED on off. Every 10 milliseconds, the last LED will be glowing. Yes, for every 10-20 milliseconds, this last LED will be glowing. Whenever I press that button, the code will stop. See here, I go to my, sorry. I'll go to my front panel. I save this code. I run this program. Close. Now I am using a mouse to stop my program. My program stopped it. So now when I run this program, you see here, were you able to see this 10 millisecond variation? No. This is continuously glowing. Yes or no? This seems to be continuously glowing. When I press this button here, the code stopped there. So no, program stopped. So in order to show the delay there, sorry, I'll increase this time delay half a second. Every half a second, up and down there. Yes? So quarter second also you can see. So save changes, window, run your program. Okay. So now do you see? Oh sorry, I touched the power supply. Yeah. Code is deploying. So now what I'll do is, code is running there. I removed this system from my system. I removed the MyView from my computer, but still MyView is working because it has an FPGA in it where you dump a code, it will work. Yes? Do you see that 500 millisecond blinking now? Earlier this was not happening. Actually it is happening. 10 milliseconds we can't see. Yes? So whichever direction I tilt, those LEDs will change now. Yes or no? Yes? So whichever actions I change, it will work there. But the problem here is, when there is a power loss, when power comes back, the system will not work because it is volatile. So now, for that, what we do is, there is one person in this system working. Who it is? A real-time computer. I have to assign work to that real-time computer. How exactly when your system starts, it is booting with Windows 11. If you have multiple OS, you will be choosing a particular OS, right? Similarly, I have to tell this computer, whenever you start, you load this VA. Am I clear? Whenever you start, you load this VA. So what I'm going to do is, I do all changes to this, save, close. So now what I'll do is, this main VA, I want to check whether the functionalities are proper here. Before I deploy it, I will verify all the functionalities are proper here. So code is running, I press the button, so code stopped. Yes, code stopped over there. But the problem here is 500 milliseconds is too much time. So now I try to reduce this with a 250 or 200. 200 millisecond time delay. File, save changes, run, close. Yes, it stopped there. File, close. So now I will be building this VA for my application. So I try to build an application for this, a real-time application. I try to deploy into this system. I am building a real-time application to this. An RTXE file, real-time application file, where I am going to build. So which is your source file? This main VA is my source file. Startup VA. When this machine starts, this is the startup VA. So I push this over there, I say build. So this device is building over there. So once this exe is built, then I can deploy this into my RT. These students know that. They don't know about my M-Trick. Why did you add the file training for it? On my website. Plan for it, they will also learn it. Yes. So now if you see, this build is completed. So I done with this build. I dump this as a startup, set as a startup option. So now what will happen here is, I run as a startup option, so this will be deploying into it. So I am deploying this entire code, whatever I have made now. I am deploying inside my MyView there, then I totally remove. So only thing is, now once after programming your chip, give only power supply, system will work. Then you don't want any elements to be there. So now code is deployed successfully. I say close. Now it is asking you to reboot your system. I said yes. So now system is rebooting. So when system reboots, so we all know it will automatically disconnect and connect to our system. Yes. So system is rebooting. I'm just choosing do nothing. So now what ideally should happen? What ideally should happen when the system is only powered on? Yes. when the system is only powered on, the application has to run in it. Application is running in it. We are only giving power supply. Let's say I dumped this logic already here. What I have to do if I connect it to any power supply? Yes, if I connect it to any power supply here, so system is powered on. Automatically, that application should run here. We didn't write any code for this. We didn't do anything. Already, whatever we configured, you deploy to it. You give only power supply to it, it will work. So these all will become deployable targets. Assume if you have a Wi-Fi connected to this. Yes, assume you have Wi-Fi connected to this. Wherever you are there, whether you are in a ground floor or lab, you connected to a college campus. This hardware is sitting on the last terrace, which is measuring a solar panel voltage. You can read over there. And his job is only to do. So now the application is running over there in it. I need to stop the application. What should I do? Press the button. So application stopped. It is nowhere running. How do I restart the system? How do I restart the system? Where is reset? I am saying restart the system. Restart the application. How do I do that? Remove the supply and connect again. See, basically you need to power cycle the system. I told you again, when the power is there, system will function. Now you switch it off. So power is not there. Power is there, device is connected, but application is not running. So what do? You need to turn off the system and you need to turn on. You need to reboot the application in the sense power off and power on. Power off, power on. So now once the device is on, x-axis is high, first and last will be on. And the last one will be blinking, first one will be always high. Working? So only thing is, you need to write a program. Same logic is functioning here. So only thing is, now this has become, instead of a reprogrammable, this has become ASIC. I built one code, I deployed here. Tomorrow I don't want, I erase this and change to other 500 ml liter water bottle. Yes, 500 ml water bottle plant will become 1 liter water bottle plant. So you can modify and change it there. Am I clear? Yes. So only thing is, if you have the right system with you, you can easily build things there. Now we didn't do any compilations. All compilations has been done by LabVIEW itself. I didn't write a single line of code. I told you in the very first beginning. Everything I did graphical, but still I'll be able to achieve the output from a real-time sensor. I read the value, I give to an LED, and LED is responding for it. So similarly, if I do the same, I can do others. Yes or no? See, same feature you have in your mobile phone as well. Your mobile phone have accelerometer. If you flip either directions, you can see. I don't know how many of your mobile phones has the feature of. Whenever you get a call, just flip your phone will go to silent. Yes? So, what you can do it is, you have this element. If you just flip based on the accelerometer only, you are doing the work. So now, when I flip or do any the orientation changes, I am getting an LED here. So now I have to give a signal to the ringer. Turn off, turn on. Am I clear? So application, whatever you're gonna develop, it's the same applications what you have there. Any doubts? So this you can pass to others, sir. Everybody can see it. Ma'am, I have feedback forms.
think how you work this round. Okay.
Thank you very much, sir, for your highly informative and engaging session. Your valuable insights, practical demonstrations, and industry expertise have greatly enriched our understanding of the topic. As a token of sincere appreciation and gratitude, I request resource person, our esteemed resource person, Mr. A. Manimaran, for the presentation.
Thank you.
Sir, sir, and thank you, sir.
Thank you.
Keep